Okay, we've officially hit the exponents. We've got to simplify this without using a calculator, and we always do the inside of the bracket first. So I'm seeing negative exponents, so we're going to use the negative exponent law. And just to briefly run through how that works, if I have a negative exponent, I take it to the other side of the divide line, and then the exponent becomes the opposite sign of what it used to be. So we're going to apply that to this 2 to the negative 1 as well as this 3 to the negative 1. And if they're not a fraction, I make them a fraction simply just by putting them over 1. Okay, now we're going to move them. So if we move the 2 over, look how the exponent changed from negative 1 to positive 1. And 2 to the power of 1 is just 2, so I can simplify even further. And now it's the 3's turn to get Chizinyonke over to the other side. And don't forget to change it from a -1 to a +1 when you do that. And 3 to the power of 1 is simply just 3. And then we're going to wrap that up in a bracket with a square on the outside. Okay, now I'm adding 2 fractions on the inside of the bracket. So I smell an LCD cooking in the kitchen, but... So the smallest number that 2 and 3 fit into will be 6. There is a way you can check that on your calculator. So you press alpha, and then you press this button over here to activate that LCM. And then you hit a 2, and then you separate it with the semicolon. So you press shift, semicolon, then you press a 3, close up that bracket, press equals, and it tells you the lowest common multiple of 2 and 3 is 6. But don't tell anyone about this one, because we're supposed to do without a calculator, my bro. Okay, so LCD is 6. What do I need to times 2 by to get 6? I need to times it by 3. And whatever I do to the bottom, got to do to the top, my chum. So 2 times 3 gives me that 6 over there. 1 times 3 gives me that elegant little 3 over there. Okay, what do I need to times 3 by to get 6? I have to times it by 2. And now I want to morph them into like one big fraction like this. And you really want to get comfortable enough to do that all in one step. It's a very powerful tool in maths. So we are going to be left with 5 over 6 squared. And now I'm going to shower the power to the top as well as the bottom. And I'm just going to take a couple of seconds to over explain this so you understand it. So that 5 is actually a 5 to the power of 1. And that 6 is actually a 6 to the power of 1. So when I shower the power, I'll multiply exponents. So if I shower the power to the top, it becomes 1 times 2, which is just 2. And when I shower it to the bottom, same thing happens. 1 times 2 is just 2. And then 5 squared is 25. And 6 squared is 36. And now we're clear, bro. We finished, man. Alright, so they didn't say we can't check our answer with the calculator. Hint, hint, nudge, nudge. So let's slap that in the calculator and see what it gives us. Okay, so we clap that in, press equals, and then a Chizinyonke is my answer there. So now I know without a shadow of a doubt, I am correct, my bro. Okay, and the 3 marks come from converting these exponents to fractions, the simplification behind the fractions inside the brackets, and 1 mark for the final answer. Carrying on with our exponential expressions, this one over here is a lot different to the last one. And this minus is actually telling me something. That eventually down the road, I'm going to need to factorize in order to simplify this fraction. But there's quite a few things we're going to have to do before that. So I see some composite numbers, this 4 and this 4. And firstly, I'm going to prime factorize them. Okay, so this 2 will stay over there. And then if I prime factorize this 4, I get 2 squared. So I just changed the 4 to 2 squared. Just remember to keep it wrapped in brackets. And there is a way to check that with your calculator. So you press 4 and then equals. And then you press shift. And then you see that fact over there. So we press this button and it shows you prime factorized 4 will give you 2 squared. Very useful tool. Okay, now I see another 4 over here that is going to get prime factorized as well. And just remember, brackets bless your life, my bro. Okay, and then nothing else about the structure changes. This 4 is still being raised to the power of x minus 3 as we saw it over there. Okay, now we're going to analyze the bottom, see what we can do with the bottom. And at the bottom here, I can see we're multiplying the same bases, so we will be using exponent law 1. If I'm multiplying the same bases, then I add their exponents together. So I'm going to do exactly that with the bottom over here. And if I say x plus x, that's going to give me 2x. Okay, and that's step number 1 out the way. Okay, now these brackets are bugging me. I want to find a way to get rid of them. And we are going to get rid of them with exponent law 4. If I've got an exponent raised to another exponent, then I multiply those two exponents to simplify further. Okay, but this one's got a bit of a twist. I'm saying 2 times this whole thing. So I've got to distribute that 2 to both of them. And when I distribute, I multiply. So this 2 will just stay there. And then 2 times x is just 2x. So I'm going to get 2 to the power of 2x next to that. And then 2 times 2 will give me a plus 4 over here. Okay, now we're going to shower the power over here. 2 times x is 2x. 2 times negative 3 will give me negative 6. And the bottom is just chilling. He's like, leave me alone, dude. Okay, and now we're going to need to split these up in order to factorize. So let me show you what I mean by split them up. So it's the exponent law we saw earlier, that if I multiply like bases, you add the exponents. But we're going to do that backwards. If we're adding the exponents, we split it up into 2 like bases, where they're raised to the power of each exponent separately. So we're going to be using the reverse version of it. Okay, and then just to illustrate how that's done with this first one. So my first one is going to be 2 to the power of 2x, represented over there. Then the second one is going to be 2 to the power of 4, represented over there. Then I'm going to slap this minus sign over there. And then we hit the banana split with this guy as well. So the first one will be 2 to the power of 2x. And then the second one will be 2 to the power of negative 6 over there. And then the bottom's just chilling. Okay, and after that tedious work has been done, we are ready to factorize, my friends. So if I have a look at the top of the fraction, I can see that they have this 2 to the power of 2x in common. So I'm going to remove it as a common factor. And how we do that is we write it in the front like this, and then we open up a bracket. Then we're going to see what's left over. I removed this 2 to the power of 2x as my common factor. So there's a 2 times 2 to the power of 4 left over with the first term. Okay, the minus will stay in the middle. And from the second term, I removed this, so I'm only left with a 2 to the power of minus 6 in the second term. And then the bottom chills for one last time. And then here comes the satisfying part. You see the 2 to the power of 2x and the 2 to the power of 2x. I can cancel them. Slap, slap. And you can only cancel when it's outside the bracket, when you have one term over one term. And while we're here, let's quickly simplify this. So I'm seeing I'm multiplying like bases, so I'm going to add their exponents. If this 2 does not have an exponent, we assume it's 1. And 1 plus 4 will give me 5. So I'm going to get 2 to the power of 5 minus 2 to the power of negative 6. Okay, now we're going to start simplifying. 2 to the power of 5 is 32. Triple check with your calculator if you're not too sure. Okay, 2 to the power of 6 is 64. But since it's 2 to the power of negative 6, it's going to be 1 over 64. Because of that negative exponent law that we did discuss in the previous question of how we change 3 to the negative 1 into a third. And then we've got to do that without a calculator. So the easiest way to do it is like this. I break this 32 up into 32 plus 1. And then I change this 1 into a fraction of 1 over 1. And then I want to find an LCD between these two fractions. It's going to be 64. So I have to times the top and bottom by 64 here. And 1 times 64 is just 64. Same will happen at the bottom, so it will convert to 64 over 64. And now that we've got the LCD, we're going to like morph these into one big fraction, like so. And 64 minus 1 is 63. And then we can write this as a mixed number. 31 plus 63 over 64 is just 31 and 63 over 64, like this. It's almost like saying 1 plus a half is 1 and a half. It's kind of the same principle that's happening over here. Alright, so there is our final answer. Quite a hard for 3 marks in my opinion. Let's have a look where they're coming from. Okay, so 2 marks are going to come from the correct factors in this line, and then you're just going to get 1 mark for the answer. So me personally, I would kind of use my calculator to help me save time over here, because doing this all in your head is just going to waste up a lot of time. Next up, we've got a nasty cocktail of surds as well as exponents in the mix here. So with BODMAS, we always do what's inside the brackets first. If we have nested surds like this, we do the one on the very inside first. So this 3 to the minus half, I'm going to leave it there. And I'm going to start focusing on this root 12. Okay, now how I simplify that root 12 is actually quite complicated. So I've got to ask myself, what perfect square will fit into 12? And you can't use 1. So I ask, does 4 fit into 12? It does indeed, my friend. So we found the perfect square that fits into 12. And then I ask myself, 4 times a number should give me 12. So 4 times 3 will give me 12. And now I'm going to use a surd law. And surd law 1 states, if you have 2 factors underneath a big square root, you can expand the factors into 2 separate square roots. And the square root of 4 will just give you 2. And we can't square root 3, so we just leave it as the square root of 3. So this root 12 will simplify into 2 root 3. And you want to kind of get comfortable enough to do that all in one step. Okay, don't tell anyone I told you, but your calculator can do this for you. Square root of 12, crispy 2 root 3 there, but. So 6 years later, we convert the root 12 to 2 root 3. Now over here, I'm going to leave this cube root and I'm going to change this square root with exponent law 5. So basically, if I have a surd, I can convert it into x to the power of a fraction. So this number here goes on top. If there's no number there, we assume it's a 1. And then this number here goes at the bottom. And if there's no number there, we assume it's a 2. So if I had to convert this into a fraction, it would be 3 to the power of a half over here. And then we're just going to wrap it up in our square brackets. Okay, now using the same exponent law, this square root of 3 over here, I'm going to change it to 3 to the power of a half. And we do that because we know more exponent laws than surd laws. So if we're working with exponents, we're in a more familiar territory and we can simplify a lot easier. Okay, now over here, I see I'm multiplying like bases, and this one doesn't have an exponent, so I assume it's 1. So we're going to be using exponent law 1 over there. If I'm multiplying like bases, I add the exponents. 1 plus a half is 1 and a half, also known as 3 over 2. And while we're here, I want to change this cube root. So how I change that is I wrap this in a bracket, and then I change it to the power of 1 over 3, just like this. And now we are starting to get somewhere. Now there are no more surds. What a dream. Okay, so let's simplify what's on the inside of the bracket first. So over here, I can cross cancel these 3's. So we're gonna slap them out of here, my bro. And then we're just gonna be left with 3 to the power of a half over there. Okay, and just in case you're curious as to how I get this off, top times the top. So 1 times 1 will get me that 1. Bottom times the bottom. If this cancels, there's a 1 left over. So 2 times 1 gets me that 2 over there. Okay, we're almost there. Now we're going to distribute this into the bracket. Okay, so I've distributed that in there. And then I just kind of put the 3's next to each other to set myself up to use exponent law 1 again. And then over here, we just slap them next to each other. Now we can see the same base here and here, and they are being multiplied, so I can add their exponents, and the same will be true over here. Okay, so let's add them up together. Minus a half plus a half. And that's going to cancel each other. We're going to slap them out of here, bro. So what we're going to be left with at the end of the day is 2 times 3 to the power of 0 plus 3 to the power of 0. And anything to the power of 0 is 1, my butt. And the calculator concurs with me, also tunes me 1. Check it this, bro. If I change this to 7 to the power of 0, guess what it's going to give me? A crispy little 1, but engine number 1. Okay, so let's change these to 1s. And 2 times 1 is just 2. And 2 plus 1 will give me 3. Okay, and then I never trust my work for the simple fact of I am a human being. I do make mistakes. So I want to find ways to check my work. So I'm going to slap this into my calculator, press equals, and how's it? But yeah, we get 3. The calculator agrees, my bro. Okay, let's have a look where those 4 marks come from. Okay, simplifying what's inside the brackets gets you the first mark. Changing the surds to exponents gets you the second mark. Having the correct factors present over here gets you the third mark. And the last mark comes from the answer of 3.